Hi everyone, welcome back to the channel Coding Help. In this video, we are going to solve the problem of Click Contest 491 minimum bitwise OR from the grid. We need to find minimum bitwise OR, and we have given the grid m cross n. Okay, now how we can find the minimum bitwise OR? Let's understand with this example. They have given the m cross n grid 2 cross 2, and we are finding we need to take one value from this row and one value from this row, and we need to do the OR operation. After that, we need to find minimum from the all of combination. So in this case, what are the combinations possible? 1 with 2, 1 with 4, 5 with 2, and 5 with 4. So 1 with 2, when we'll do OR, so it will give you 3. So that will be the minimum one. Okay, same in this case, and it will give you 5. So what will the our brute force approach? Let's take example 3, 5, 6, 4. First take this one and this one. 3 and 6. What will the OR of this one? This will be the 7. Right? 6 is 110. 3 is 11. Do the OR of this one. This will be 111. This will give you 7. Then 3 and 4. Okay, this combination 3 will be this one and 4 will be this one. This will also give you 111. Again 5, 6. So 5 will be 5 and this will be 6. This will also give you 7. Then 5, 4. 5 and 4. This will give you 101. This is 5. This is the minimum bitwise OR. So in brute force, we need to explore all the combination. So how we can approach the brute force? We will send the row, we'll send the bitwise OR in DFS. And in every DFS, we will run the loop from 0 to m. This is for column. Okay. And till 0 to n, this DFS will run. Okay. So for DFS, from 0 to n, it will be DFS. And for every index, we need to run this m. You can say m, n is for DFS, then m, then m, then m. How many times? N times. What will be the time complexity? N into m to the power n. So what is our constraints? Let's check. Our constraints is 10 to the power 5, 10 to the power 5. So this will give you very large time complexity. So it won't be accepted by LeetCode. Now what we can do? We can memoize. Okay. We can do memoization. How we can do? What are the variable we are passing? We are passing the variable index and XOR value. I index we are passing and OR value. So we'll memorize this one. Okay, this will be our key. So we can use any hash map and make the key of index and OR. We will store the value. Okay, right? So in this case, what will be our time complexity? Because we are memorizing this one, this one, this one, I, OR, and in every DFS, we are running the one for loop from 0 to m. So that is also there. What will be the range of I? 0 to n. It will give you n. What is the range of OR? Let's check. Maximum value is 10 to the power 5. So maximum OR will be also 10 to the power 5. So that's why we will take 10 to the power 5 and n. Oh, sorry, m. N into m is n into m is 10 to the power 5 and this is 10 to the power 5. So it will give you 10 to the power 10 time complexity. If any code is running above the 10 to the power 9, so it will give you TLE. But still we have optimized a lot. Let's check the TLE code with memoization. This is our TLE code. Here it's a 950 test case is getting passed. So this code what we are doing, we are taking one memoization and then grid and m. Okay. We are passing this DFS 000 is for row index and this 0 is for or value. So when row is equal to m, it means that we are going out of the row. So we are returning simply or value, and we are making the key to store our memoization value. Okay. So if we are getting that key value, it means we are returning memoization value. We don't have to go for again recomputation. Otherwise, what we are doing, we are checking for each value. We are going another row, taking one value, doing or going for next row. Like that, every time we are checking this one, and finally we are storing minimum value. Then here in memoization, we are putting that minimum value, and finally we are returning the minimum possible XOR. Okay, so it will give you TLE. Now, how we can approach the optimize approach? Now how we can optimize this code? So we need to think greedy way and bitwise way. Okay, so our value, how much our value is there? 10 to the power 5. How many bit it will take? For 1k it will take 10 bit, and for 100 it will take 7 bit. It will take overall 70 bit. So what we'll do first, we will set all the bit, all 70 bit, and then in example what we'll do, we will try to unset this bit. Okay, so we will start from MSB. We will try to unset this value. If we will be able to get our answer within this set bit, then we will keep it a 111. So we are trying to reduce the mask. Okay, so let's run with one example, then we'll understand. What was our last example? Last example was 3, 5, 6, 4, I think. Let's take our mask as a 7. Let's take it. Now we want to remove this bit. Okay, what will be our mask? This one. In the for loop, what we'll do, we will take this as a 3. Okay, this is our mask. We will take 3 and we'll do OR with this 3. Okay, OR operation. And we will check after doing OR operation, this is same as mask. If this is same as mask, then we will go for the next row. Again, we will do 110. This is same as a mask. It will give you 111. Yes, this is same as a mask. Then we can set this bit as a 0. Now we can set this index as a 0. Okay, that done. Now again we will try to unset this bit 0 1 1. Now try to find the mask. Okay, do 3. What will the OR? It will give you 3 only. Okay, this is same as a mask, our previous mask. This is our new mask. Okay, okay, next time we will take 6. This will give you 1 1 1. This is same as a mask, previous mask. No, this is not. Then we will go for this one 4 1 1 1 0 0. This is again 1 1 1. This will give you 7. This is same as the previous mask. No. So if we are not able to set this bit as a 0, we will do all the operation. Like for Again, we can do using this one. Like we'll take this 5, 101. Here only it will give you 6. It will give you 7. Here only this will break the loop, and it will say we want to be able to find the minimum or value when we will reset, or when we will set 0 to this index. So definitely we need to set this bit. Okay, now we need to set this bit. Now we'll try to unset this bit. Okay, so unset, we will take 3. It will give you 7. This mask is same as this. Now we'll go for next one, our 5 value. What is the value? 4 or 3, 5, and 6 or 4. We'll go for 5. Our mask is this one and value is this one. So what will be the our mask? We'll do our operation. So what will be our mask? 101. Okay. So this is same as mask. Yes, this is same. This will give you 111. This is same as mask. Yes. Now we'll take, go for next row. We'll take 6. We'll get 111. This is same as a mask. No, if this is not same as a mask, what we'll do? We'll not check this one, go for this one. Again, we'll check for this one. Okay, now this is same as a mask, 101. Yes, this is same as a mask. So we can unset this value. So now our value is 101. See, little bit we are reducing. What we are doing? We are reducing, try to compress the value. Now we'll try to unset this value, 100. We'll take 3. It is same as this mask. No. We'll take 101. It is same as this mask. No. Okay. So we won't be able to, if we are finding we are not able to get this mask, so we'll not go for next row. If we will pass the current row, then we will go for next row. So in this case, what will be our time complexity? Because we have 17 bit. Okay. Then every 17 bit we are looping through all n cross m grid. So our time complexity will be 10 to the power 5 into 17. This want will give you TLE. This will accept. Okay. Now let's go for the code. See, this is accepting the code. We have set all the 17 bit. Then we are starting to set the MSB bit. Okay. If they are checking if it is possible to unset bit, after unset we can find the minimum or value. So we are checking here row, then every number we are doing or. If we are able to get nums or mask is equal to mask, then we will go for next row, right? We are breaking current row. Finally, when everything is okay, anywhere we are not able to find the false, so we will return true. Yes, we can find the value after unset that bit. So we are putting mask as a new mask. Okay, mask as a new mask. Again, we will try to unset current index, if we won't be able to unset, just we will set that bit, right? So this is our solution. Okay, if you want to be able to understand this code, just try run some example. Definitely you will get the solution. Thanks for watching. We'll see you in the next video.